wherever you might be on the globe. I believe we have something like 250 to 300 registrants for our GeoServer 2.28 and beyond webinar, representing something like 50 to 60 different countries. So that's really exciting news. We appreciate your time today and joining us. My name is Ryan Burley. I'll be doing a quick introduction on GeoSolutions, and then I'll pass it over to Andrea, who is our GeoServer expert and Saul Katz award winner from, I believe, 2017. So you're in the right place for all things GeoServer. Just a brief word about ourselves, if I can get this to work. So we've been doing this for a long time, right? Close to 20 years, and we have expertise across the open source ecosystem, everything from PostGIS to GeoServer, all the way to QGIS even, right? But the main products that we maintain, support, that we're on the steering committees for are GeoServer, GeoNode, and MapStore. GeoServer will be covering today. GeoNode kind of ties everything together as an SDI management system, content management for geospatial data and beyond, allowing you to create dashboards, manage all of your data. It could be video data, any type of multimedia data, and then MapStore is the front end product, right? So we have previous webinars stored on our YouTube site on these other projects and products. If you're not familiar with them, we highly encourage you to reach out to us or check out our YouTube site. There's a lot of information, documentation out there on those products. A lot of times we're asked, hey, how do you guys make money in the open source world? But it's a viable question, right? We focus on commercial support for open source, as we are the maintainers or some of the core maintainers and steering committee members for GeoServer, for example. So you have a direct line of communication to the core code developers for GeoServer, GeoNode, and MapStore. There are a lot of different ways we can support customers, from deployment subscriptions, hosting services. Obviously, we offer a full catalog of professional training for all of these products, and customized solutions as well. So any type of application that is getting data from a sensor to an end user application, front end application for analysis and visualization, or spatio-temporal data, if you will, weather data, moving points, anything moving within space and time. That's our sweet spot, and we're always happy to support those applications. We've worked across the board when it comes to different verticals, right? So all levels of government, from local all the way to federal. You'll see some examples here from insurance and risk, insurance and reinsurance, Guy Carpenter, everything from local cities, smart city, very large scale, zoomed in areas of interest, all the way to global satellite companies, satellite operations. Again, some of the verticals that we work in: utilities, agriculture or precision agriculture, smart cities, emergency response is a big one, right? Helping out with evacuation routes, for example, as conditions change in specific areas, and getting that data out to mobile devices. These are all things that we have expertise in, and that we're happy to support you and your organization with. Some of the industry groups that we're involved in, and again, so much of this is community-based, right? So if you're not already following OSGeo, there's a Slack channel for OSGeo US specifically. You can follow OSGeo and all the different regional OSGeo groups on LinkedIn. We highly encourage you to get involved, or at least stay tuned with the updates, because globally it is all about the network, and that's how we share knowledge. That's where the expertise transfer comes from, and it's a good way to see how different components within the open source ecosystem are evolving and stay in tune with changes. OGC, we participate in test beds, a lot of different R&D activities. We've been highly involved in interoperability standards, WMS, OGC APIs, etc. So obviously we're very tied in with OGC. United States Geospatial Intelligence Foundation, we've been a member now for several years. So you will find us at GeoInt, and we support the GeoInt community in the US federal market, as well as other defense and intelligence government agencies across the globe. Cesium, we are 3D tiles, Cesium 3D. We're a Cesium 3D certified development organization, which means that we have several developers with Cesium 3D experience. We actually have a very nice webinar where we featured the city of Genoa in Italy, which has done a lot in terms of developing 3D visualization for their smart city application dashboards. We encourage you to check that out, and there are several other examples as well. And then World Geospatial Industry Council. So WGIC as a global leader in just the industry leadership, everyone from Trimble to Esri to us on the open source side. So we tie in with the global geospatial industry network through WGIC as well. Some additional resources for you. Again, this webinar will be recorded and put on our YouTube channel, as have our past webinars. And if there's anything that you can't find in terms of case studies, examples, videos, training materials, etc., just reach out to me and I'll be happy to help out. We also have a blog on our website, which we post to frequently. That'll keep you updated on the events that we will be at, new developments within the products we support, etc. And then we also have a newsletter, which you might have seen when you registered. I highly encourage you to sign up for our newsletter because, again, that'll keep you up to date in terms of GeoServer, GeoNode, MapStore developments, as well as a lot of the applications and customers we support. Anytime, reach out to us. Reach out to me. There's my email address. We're always happy to hear how people are using GIS, how people are exploring the use of open source. Again, a lot of times it's not all one thing or all the other. If you're an Esri user or using proprietary software stacks, we talk a lot about hybridization, right? We're always here to help out on the open source integration side of things. And again, that expertise goes across the board from a variety of different cloud deployments, hybrid cloud deployments, open source proprietary stacks, a variety of different databases that we have expertise in. So whatever kind of challenge you might be facing on the geospatial side of things in your business or your operations, feel free to let us know how we can help you. And we're always happy to be a resource for you. So with that, I will pass it off to Andrea. And thanks again, everybody, for joining.
Thank you, Ryan. Okay, I'll go and share my screen. Give me just a sec. And so, yeah, let's get started with this introduction to GeoServer 228. So GeoServer 228 has been released in late September, and it has been a significant milestone for GeoServer because it represents the first step towards GeoServer 3. In this presentation, we are going to discover what's new in GeoServer 228, as well as dive a little bit into what's coming for GeoServer 3. Okay, so where are we? Well, we are more or less around here towards the end of 2025. Right now, the 227 series is in maintenance mode, and it's gonna end in March 2026. In that date, we stop releasing it. 228 is in stable mode, and it's gonna switch to maintenance mode in March. And we'll receive updates up until September 2026. And when it comes to the development series, we are now working on GeoServer 3, which is scheduled to be released sometimes around March 2026. After which it will become a stable series, and it will flip to maintenance mode in September 2026, and so on. This is the regular update cycle of GeoServer. Each release has 1 year to live, 6 months as stable, 6 months as maintenance, and then we stop making releases out of that series. This keeps a reasonable balance between the speed at which we are producing new functionality and providing a little bit of support for your deployments. If you are using an older version, please upgrade. I'm going to give you as many reasons as I can during this presentation, but one of the most important ones is that you get security updates as well as functionality improvement, new speed ups, and bug fixes. Okay, so in each slide, you will see at the bottom 3 boxes. And the middle one has the author of the fix, improvement, new feature. In the orange box, you'll get the sponsor that provided funding to implement such functionality, and in the green box, the version that that contains such functionality. Okay, we'll go through the new bits and pieces by teams. So let's start by configuration and setup. That is how you configure GeoServer. And how you run it. So first bit, first important change in 2.28, the minimum Java version for the deployment has become Java 17. It means that if you had a GeoServer, a previous GeoServer that was running on Java 11, on the upgrade, you will also have to upgrade to Java 17. At the same time, we try to maintain every build in GeoServer. The builds are is the process where we compile the sources, run the tests, assemble the results, verify that they work, and so on. Well, we run all this process with Java 17, Java 21, and Java 25, right? So while we typically deploy on Java 17, we at least know that GeoServer is running properly and it's passing the test on JDK 21 and 25 as well. Although, as I said, most of the deployments are on Java 17 right now. In GeoServer 2.27 and in GeoServer 2.28, we saw the advent of a new data directory loader. What is this thing? Well, this is the bit of code that reads all the XML files which are in your data directory. And there was a complete overhaul of this loader with a new one, which is especially designed for large data directory, for data directory which are on network file systems, and it parallelizes better, and it provides a directory scanning order that makes NFS and friends just work better. So here we have a benchmark. On the x-axis, we have the number of layers. See that we have tested with a significant number of layers. The small data directory here already has 16,000 layers. And then we tested with 100,000 and 1 million layers on NFS and on local file system storage on SSD. On the y-axis, we have the speed up factor compared to the old data directory loader. So depending on your use case, it goes from around 2 times faster to almost 8 times faster, depending on whether you are on local file system, on network file system, and how many layers you have. So if you have a very large data directory, if you're sharing it, especially on a network drive, this upgrading to at the very least to 227, but especially to 228, is going to be very beneficial for you. In 228, we added the ability to advertise attribute restrictions. So if you have a bit of familiarity with WFS and Friends, you know that we describe the structure. By the way, I see the questions, but I will answer them at the end of the presentation. Anyway, going back to the slides. The WFS protocol has this describe feature type request that is used by clients to know what's the structure of each vector layer. which attributes are there, their type, the structure, and so on. We recently added the ability to add restrictions on the attributes, like restrict by range or restrict by enumeration of valid values. And these restrictions are then going to be advertised in the describe feature type output in a standard way. This is nothing GeoServer specific. It's really just XML schema. This gives the clients that are doing WFST an opportunity to set up a proper client-side validation and also a useful interface, like think about having an enumerated list of values. You could have a drop-down in the client, for example. And then if you are doing WFST, if you are trying to modify the data, the restrictions will be applied on the transaction request, and validation will occur before doing any changes. So if you try to perform an update with a value which is not in the list or outside of the valid range of values, the transaction will be aborted. Also, from the point of view of configuration, we now have an optional opt-in feature to track which user modified the configuration last. This is useful for environments where you have more than one administrator. You want to know who modified last particular layer, service, store, style, and so on. Again, this is not happening out of the box by default. It is something that you have to enable in GeoServer as the global admin. There's actually a system variable to enable it. And when you enable, then GeoServer will start tracking and recording who made modifications to the configuration. Also, from the point of view of, let's say, security and administration, starting with GeoServer 2.27.0, we have this file system sandbox configuration. The idea is that administrators can be sandboxed into a particular subset of the file system. So think about cases where you are configuring a shapefile or a geotiff, and you use the GeoServer browse file system functionality to go over the file system and find your data files. Well, normally you are allowed to browse pretty much anything that the GeoServer itself can see, which can be too much. So right now we have this opportunity to set up a file system sandbox so that administrators are limited to a subset of the GeoServer file system. And in particular, the global admin will be limited to one particular path, the sandbox, which can be configured by a system variable. And in that case, the user interface for it is shut down so that not even the GeoServer admin can change it. And the workspace admins are going to be limited to subfolders of this sandbox, which are named after the workspace itself. Long story short, you can have all the admins limited in one part of the file system, and the workspace admin to a subset of the file system which is dedicated to the particular workspace, which, generally speaking, enhances security and provides for a better experience in multi-tenant deployments. Again, from a, let's say, configuration point of view, but not 100% configuration per se, it's the EPSG database update. We have been running over GeoServer, over the EPSG database version 9 for a number of years. The upgrade was a bit difficult because around version 10, EPSG has modified the structure of the database tables to some extent. And in GeoServer 2.27, and so also in 2.28, we have finally made the switch to version 11, thanks to the sponsorship of Deutsche Bahn. And this, well, provides a number of benefits. In particular, we got more EPSG codes, which means we cover a larger variety of coordinate reference systems. And also, we have a number of fixes and improvements on datums and similar um, information, which should improve the quality of the coordinate reference system transformations. Moving on, this was what we have in terms of configuration. Let's have a look at mapping. What can we do that's new in terms of mapping? Well, this is something that has been as a desired item for a while, which is support of the transformation functions in Legend Graphic. Now, sometimes in styles, you want to just have one item in your style, like the color, for example, be driven by an attribute. And in this case, for example, we are taking an attribute called subregion. We are trimming eventual white space around it, and then we are mapping it. Each area of the United States gets mapped to a color. It is very compact. It's fast. It always had one annoying downside. You couldn't get a proper legend graphic out of it. Now, starting with GeoServer 228, the legend graphic generation system understands functions like recode, interpolate, and classify, and will generate a proper legend for you. So you get the benefit of compact and fast SLD without giving up the legend graphic. The raster processing engine, which is used for all mapping, has been replaced, or more than replaced, let's say, upgraded. So historically, we have been working on Java Advanced Imaging, which was then compounded by JIXT, which was a project managed by GeoSolutions to extend and improve some of the JAI image processing operators. Now, a few years ago, the Eclipse Foundation managed to get Java Advanced Imaging source code donated to Eclipse under a fully open source license. And we took the opportunity of the GeoServer 3 funding to take the source code, the old source code of JI, the source code of JIXT, and turn them into a new project called Imagen. Imagen will be the foundation of raster processing for years to come for GeoServer. And right now we are just scratching the surface of what we can do with it because we were busy taking the two code bases and merging them into one. But now that we have full control over the source code, we have an opportunity to make extra improvements, fixes, and performance enhancements that we couldn't do before due to JI being closed. Moving on, data sources and formats. We have some interesting news in terms of data sources. One that I like personally very much is the ability to use GFOL, our raster algebra, in coverage views. What does it mean? Well, say that you have a raster with many bands or an image mosaic, again, with many bands. What you can do is to, with coverage views and friends, is to select bands and make a false color image. And that is something that you have always been able to do. What you couldn't do before was to bake into the layer definition the a script, an algebra script that computes on the fly an index of some sort. In this case, NDVI based on Sentinel-2 source. This is beneficial because Well, you could do it before, but you could do it only in SLD. Doing it only in SLD limits it to only WMS. Instead, if we do the calculation at the layer definition, we have a significant advantage in that we can also download the result as WCS or post-process it via WPS. So it makes the GFOL integration in GeoServer seamless, which is a bonus. We have a new community module to read GeoParquet. GeoParquet is this cloud-native format which has been in the news quite a bit lately. Parquet per se, it's kind of the cloud-native replacement of CSV. So it's designed to contain a table in an efficient cloud-native binary format. And GeoParquet is the geospatial extension for Parquet, which allows columns to contain geometries as well. It has a little bit of support for bounding box filter optimization, as well as alphanumeric filter optimization. GeoServer reads the GeoParquet files from local file system, from HTTP, and from blob storage. By blob storage, I mean AWS S3, Azure blobs, or Google Cloud storage. We do the reading through DuckDB, which has proved to be very fast. So it's a very interesting solution. Generally speaking, where does this shine? In situations where you have very large files that do compress well using Parquet, because Parquet is this column-oriented format that performs very good compression of your data. In cases in which your larger data sets would not fit anymore a relational database because they are too large, cases where you wanted to store the data in blob storage to save money. And so, yeah, with this, you can connect the GeoServer directly to one Parquet file at a time, or if you use the vector mosaic extension, you can mosaic these Parquet files to provide an integrated picture that covers a larger area or maybe goes through time. One Parquet file per time, for example. We also have a new PM Tiles community module. PM Tiles is, let's say, the cloud-native equivalent of MB Tiles. Both MB Tiles and PM Tiles are single file containers for tiles. Typically, they contain vector tiles, but they could contain also raster tiles as well. GeoServer can connect to a PM tile file stored again in blob storage, local file system, or HTTP, and then generate maps on the fly. So the use case is putting a PM tiles file in your blob storage, maybe make it also public. A client that can read directly the PM tiles can connect to it directly, but clients that need WMS, WMTS, and friends to make sense of the file contents and display a map can do so through GeoServer, which would render the contents of the PM tiles into PNG tiles, for example, or JPEG tiles. We also have this new community module, which is called Single Store. Single Store is it's a commercial distributed SQL database that can work in memory and can be pretty fast. It's storage that is meant for analytical workloads, and it's designed for low latency queries at scale. You can distribute the storage over multiple nodes, parallelize the queries, and so on. Single Store has a simple spatial support. It only supports geography types, and GeoServer does its best to communicate to this Single Store by also optimizing the queries, taking into account that they really are meant for geography storage. So just to give you an idea, what you think as a bounding box in WGS84 actually looks like this in reality. And so a polygon might intersect in one view and not in the other. So GeoServer took all the steps necessary to make sure that we actually get the data that you are querying correctly. And again, this is a community module sponsored by Verizon. Okay, let's move to services. We have had a year-long large push towards OGC compliance. So back in the days, several years ago, GeoServer was being certified compliant every now and then. For every few releases, we were standing up a test server and then going to the OGC test harness for compliance, which is called site. Point site to our deployed GeoServer and run the validation, and then eventually get also officially certified. During the last year and a half, we started a process of certifying again, but with a twist. We took the site certification engine, which can actually be run on your machine as well. It doesn't need to run on the OGC websites. And we made it run through Docker images for every single code change that we perform in GeoServer. So every time anyone makes a pull request against GeoServer, we run all the site certification tests for a variety of standards. You can see here WMS, WMTS, WFS, WCS, OGC API features, OGC API tags, as well as testing the certain output formats like GeoTIFF and GeoPackage, with more tests coming with time. Every few months, we actually add one more site test to that list. Now, the site test is a great way to perform functional testing against GeoServer, and it's also a great way to make sure that we don't, by mistake, introduce changes that would break compatibility with the standard. We are also running all the tests with Java 17, 21, and 25, making sure that GeoServer is running and certified with all these Java versions. In addition to that, so this test per se only run the validation and make sure that we are compliant, but that does not equate to certification. Certification is a formal process where you stand up your servers, you run the test through the official OGC engine, and then you tell OGC, oh, look, I ran the certification and these are the results, and you point them to your results, and then they certify you. The certification also goes through a step of paying to be certified. So for each service that you certify, unless you are reference implementation, and there are like a couple of reference implementations for each standard, but unless you are a reference implementation, you gotta pay to be certified with the standard. And so, thanks to some funding that was left out of the last site certification push from Gaia 3D and OSGeo UK, we managed to pay around, I think, $500 to get certified on all these standards, some of which we are a reference implementation of, and others which we are not. Again, going back to OGC APIs, and in particular to OGC API features, OGC API features has become an official extension. So OGC APIs have been supported by GeoServer through community modules for a while. The downside of community modules is that they are not part of releases, they are only part of nightly builds. And then we push each module up to extension when we think it's ready. Ready means that the standard itself is finalized. It's not going to change on us. So for example, right now, OGC API coverages is a community modules and cannot become a standard module in GeoServer because the standard itself is not finished. So we need that. We need a good test coverage. We would like to have site certification for the module, just to make sure that we have implemented it properly. And OGC API features is ticking all of these boxes. It has been implemented for a long time. We implement a number of extensions. It passes the site test conformance for the site tests that are available, which are for core and CRS by reference. But for example, filtering and SQL2, they don't have a test yet. So we have an implementation. We cannot be sure it's correct because OGC hasn't shared yet a certification test harness. In any case, OGC API features is available. You can download it. It's gonna by default enable only the parts that are fully finalized, and there is a way to configure the parts that are not finalized yet through configuration. So, for example, this is the old user interface to configure the conformance classes. So, if you wanted to have a filter, you'd have to go and checkbox and click this checkbox to enable filter support in your deployment. Going to another standard OGC API processes. This one literally went from 0 to hero in a matter of a month. So we didn't have OGC API processes at all, and then we got sponsorship from EC, ISSI, or I mean whatever is the correct way to pronounce it, to implement OGC API processes. And we did a full implementation. We actually went a little bit beyond full because we also took the opportunity to build a GET support for OGC API processes. So this means that you can use a GET request to run simple processes for you without having, to make a post request. I don't have the details, but if anyone is interested, I can pick up a dedicated presentation and show you the difference. The idea is that normally you would write a JSON document which represents the request and you post it through OGC API processes and then get the result. With GET, you just follow a URL and get the result directly. And also we are very close to be site compliant. There is a couple of things that we need to fix, probably in the test themselves rather than in GeoServer. And we are talking with OGC to get those fixes in. There are other OGC API community modules that are pretty interesting. So there is Maps, for example. Maps API is the replacement of WMS. It contains, pretty much the same functionality as WMS. The standard is finalized, but we don't have a site test. Coverages, as I mentioned, the standard is still in draft. We have processes and tiles. Both, they basically pass the site compliance minus a few fixes. Processes we just talked about. Tiles is the equivalent of WMTS. We have a stack. We have also a styles API. Styles is quite interesting in my opinion. It's a draft standard to just publish a catalog of styles so that the clients can pick them and use them, for example, in client-side rendering. Say that you have vector tiles and you would like to have a ready to use a style. You could go to a styles API, browse the catalog, pick a compatible style and use it client-side. There's also API records, which we still haven't implemented, and we are looking for funds. So records is the equivalent of CSW catalog services for the web. Okay, let's move on to distribution. So The official Docker image is moving on with the implementation. The latest version of the Docker image has been upgraded to Java 17. It's running on Tomcat 9, and it keeps on getting, that's one thing that makes me happy. I keep on seeing pull requests from the community to improve the pull request. So it's not just the developers that maintain the Docker image, but the entire community that's kind of pushing behind this Docker image to make it better. We also have a build with the GDAL native bindings ready to use. It's larger, of course, because it has all the GDAL machinery to be installed. But if you need to use the GDAL powered output formats or inputs, like, I don't know, GDAL VRT, for example, you can use this image to support the effort. Another pretty interesting development over the last few years, it's GeoServer Cloud. GeoServer Cloud is a repackaging of GeoServer as a cloud-native distribution oriented towards microservices. What does it mean? Well, it means that rather than having one single monolithic process that has the UI, the REST configuration interface, and all the OGC processes, and all the OGC services and all the OGC APIs and so on, you have separate executables that each one are running one WFS, one WPS, one JWC with tiling, one the web UI, one the REST configuration interface, and so on and so on. The interesting bit about this style of deployment, which is fully supported by Kubernetes, by the way, is that you can scale independently each type of service depending on how much traffic it's getting. So, for example, WPS under heavy load might probably need a few more CPUs, so you might want to scale this up, while, for example, GWC tile serving, especially if you have pre-seeded tile caches, can literally flood the internet with a cheap laptop. It's more a matter of having enough I/O rather than having a lot of CPU. And so, yeah, this kind of approach is well suited to deployments that have very large loads in the tens of millions of requests per day, let's say. Security vulnerabilities, yes, they do happen. We do our best to patch them. So GeoServer has its own policy for disclosure. We do coordinated disclosures. It means that we try to basically batch announcements together so that you are not running after updates all the time, but only once every few months. How do you know if there is a vulnerability announcement? Well, if you have any tool that scans your deployments, it's gonna tell you. But if you wanted to follow the GeoServer website, please go to the GeoServer blog, check the vulnerability category, and then in the announcement, you will find security considerations. This is one example where a disclosure has happened. This is GeoServer 228.1. Two vulnerabilities have been disclosed along with it. These vulnerabilities have actually been patched for a while, but we typically disclose them when both stable and maintenance have at least one release with the patches in. When we are not ready to disclose, we will still include the release announcement under vulnerability, and in the release announcement, you will find some generic text saying, hey, this release contains security fixes. We are not ready to disclose them, but please try to upgrade as soon as possible. And so, again, this is our plea for keeping your GeoServer deployments up to date. So what's cooking? GeoServer 3 is cooking. GeoServer 3 is a very large code base update that has basically been triggered by this fellow here on the left, Spring. GeoServer is based on Spring 5 right now, and we need to upgrade it to Spring 6. But doing so comes with strings attached, because we then need to migrate our base libraries from Java 2EE to Jakarta EE, which then forces other upgrades to be made. We need to upgrade from Java 11 to Java 17 and so on. So basically, we had a sort of an avalanche happening. One upgrade triggered another, which triggered another, which triggered another, and we found ourselves in in a um, in a very complex situation, because we basically had to perform a very large number of upgrades all at the same time. That's the other annoying bit. That required a significant amount of funding. It required a lot of coordination. And if you are interested in this topic, I have a few slides about this as well. Please let me know through the question and answer functionality of the webinar. Another work in progress that has been in the making for a while is the switch from Sphinx to Markdown. So this is kind of internal, but if you have ever tried to contribute to the GeoServer documentation, you probably know the GeoServer documentation is written using Sphinx, which is kind of a plain text way to generate websites. And that gets then translated into HTML and other formats. It used to be a very good format. It used to be very, very popular. But right now, Markdown is sort of taking its place. It is simpler. It has become more common. And so we are looking into ways to migrate our existing documentation from Sphinx to Markdown. The documentation that we have is very large. The endeavor is complex. We are going through a set of automated tools plus custom scripts that we have written to handle migration in places where the automated tool doesn't cut it, and a number of manual upgrades. And yeah, it's in the making, but it's still not finalized. Another thing that we really would like to do is to switch away from Jira to keep the tickets and switch to GitHub issues. It's actually harder than it seems. There are a few migration tools. They are not fully working for us. We are going to have to put some time and funding into this to make it happen. The idea is that we wanted to take all the tickets that we already have in Jira, turn each one of them, be it open or closed, to a GitHub issue that anyone can reference to, keep the Jira issue number, the title, the attachments, all the linking between issues, because there are a lot, especially considering that we would do this not just for GeoServer, but also for GeoTools. And possibly, but this is kind of a stretch goal, map users so that the same user on both ends can find it himself. And so, yeah, it's something that we would really need some help with, and some funding. And then whatever else you want to push for, because GeoServer is really pushed along by its user base. If you look at a general release, or even if you look at this very presentation, you will see that most of the features, bug fixes, and improvements come from companies that have sponsored the changes. And typically, companies like GeoSolutions act as an intermediary. We provide the implementation, we provide the contact with the community, we help you put together a proposal that would be acceptable to the community, and then we implement and we make it available in the official versions of GeoServer. So literally, GeoServer is not pushed much by what me or GeoSolution think it's best, but by what the part of the community that sponsors the development wants to push for. Our role is more like to steer this impetus from customers into a viable contribution to GeoServer and then make it happen. And with this presentation is complete. Now, if you have questions, and I see that there is already one, we have the questions and answer section in your webinar, in your Zoom interface. I'll start to answer the questions, and if there are no more questions, I'll also go over the GeoServer 3 status report because, well, 1/3 of the effort in GeoServer 3 is actually the GeoServer 228 release itself. Now, going back to the question, Paul Whittle asked a question about the data directory loader, so this page. The question says, does it mean it will not play nice with all versions? Is wondering about whether the data directory is compatible or not with the new data directory loader. Yes, it's compatible. The data directory loader is brand new software on one side, but it reads exactly the same structure. It reads exactly the same XML files. It just does it in a faster, more scalable way. So you don't need to worry about backwards incompatibilities. Bugs may happen, and it's not unthinkable that one particular data directory is not read correctly, maybe some file in it. But this new data directory loader has been out in the wild for like 8-9 months now, and I don't remember bug reports about it. So it seems to be working pretty well. Wondering if there is any other question. Again, please use the question and answer section in the Zoom client. While I wait for eventual more questions, let me also take these slides and go over, at the very least, the section that deals with GeoServer 228. Because, well, it's interesting how a good part of the GeoServer 228 code came to be. So as I told you, we have this GeoServer 3 challenge, which is kind of an avalanche that happened to us due to Spring, basically. We need to upgrade Spring because Spring became end of life on Spring 5 became end of life on August 2024, but that Spring 6 requires to run on Jakarta EE and Java 17, and so that triggered other changes. But then these trigger more changes. More changes to the pipeline. So we need to upgrade the Spring security, which means we actually need to fully rewrite the OpenID Connect plugin, which was based on old and unmaintained libraries, and we have done it already. We have been moving from Java EE to Jakarta EE, which might sound like a technicality, and it is, but the problem is that a Java library is either designed to work on top of Java EE or Jakarta EE. It's kind of a Python 2 versus Python 3 moment. So the moment we switch to Jakarta EE, any library that we depend on to also needs to be migrated to use Jakarta EE, which makes for a lot of upgrades. And in particular, it required the switching from Wicket 7 to Wicket 10. So it's kind of a large jump again. Wicket is the library that we use to build the user interface. So every time you are using the administration console in GeoServer, you are actually using Wicket. and we had to upgrade 3 versions in one shot. We know for experience that it's a difficult upgrade, so we had a sizable time allocation to do that. Migrating to Java 11 to Java 17 again can be problematic. Why? Because Java 17 is a bit more strict when it comes to controlling what you do, and GeoServer uses a large number of advanced functionality which requires reflection, and reflection starts to be limited in Java 17, and
Sorry,
it
Andrea.
gets yes.
There are a number of questions. I think it would be good to try and answer them. I'd like to see
Sure.
them.
Yes. Okay, let me try. So PM tile to WMS. We have one question about how do we go from PM tiles to WMS? Where is the code? Well, actually, the code is spread out because the code to read the PM tiles is in GeoTools. So you can find it here under modules, unsupported PM tiles here. So the source code to read the PM tiles is in this module. And I'm giving you the link in the chat. And this module per se, just like the MB tiles store, is reading the vector tiles and presenting to GeoServer as if they were shapefiles, Oracle, PostGIS, and so on. So as a vector data source. From there on, it's just the classic GeoServer rendering engine that takes over and runs the rendering with just a trick that each feature presented in to the renderer has a clipping boundary. This is kind of a technicality again, but when you enter a geometry in vector tiles, the geometry is actually not cut to the tile, but it's actually a bit larger than the tile, and then you have to render it and then visually clip it to the tile. This avoids problems with the polygon borders that you add by clipping, so that these borders are out of the view and they are getting clipped away. So yeah, this is basically what's happening. PM tiles can read the PM tiles data store can read the PM tiles structure, and it presents it to GeoServer as a vector data source with the clipping boundaries, and then the classic GeoServer rendering engine takes over and draws the map and produces the PNG output. So is there a way to hide the layer names and or groups in the URL? I'd say not, because if by URL you are talking about the get map URL, it's part of the protocol. We cannot hide layer names in URLs. If instead you meant workspace limited services, then yes, we can have a look at limiting it, but it's mostly through proxies, not directly. Then we have a couple of comments about the user interface. Will there be a lot of changes in the GeoServer admin page in GeoServer 3, and is the look and feel going to be the same? No. We wanted to go for let's see if I can find the slide. We want to go for a slightly different user interface for GeoServer 3. So the basics are going to be the same, but we are going to apply a new CSS, so it's going to look different, even if the informational content is going to be the same. we are going to try to make the user interface more amenable to large screen and small screen at the same time. We are not yet sure about which library to pick for this effort. It could be Bootstrap, but it could be Tailwind. And so, yeah, we are going to make an effort to modernize it, but we are not exactly sure yet what it's gonna look like. But for sure, you're gonna be able to know at a glance that you're looking at a GeoServer 3. We have another question about the migration, which is again GeoServer 3 specific. Do the LLMs help with the migration? Yes and no. So most of the migration, so the initial heavy lifting, has been done through a tool which is not AI powered itself, which is called Open Rewrite. Open Rewrite is a tool, a command line tool that you can apply to a code base, a Java code base in particular, to perform certain types of migrations, like going from Spring 6 to from Spring 5 to Spring 6 in one shot. And while the result is, let's say, so for example, you would run something like this to go from 5 to 6. While the result is not 100% complete and correct, it's still quite beneficial. Then again, we have been using chatbots like ChatGPT, Claude, and Gemini through the effort to tackle the hardest part of the migration. Migrating and upgrading library often means that you need to go from existing code to a new version of a new way of doing things, because the old approach was deprecated or fully removed, and sometimes it's not easy to find how to cross that gap. And so we have been using LLM to analyze and iterate over the hardest situations. Because one of the nice things about LLMs is that they are like an encyclopedia. While they are not super smart by themselves, they know all the nitty-gritty details, and so oftentimes they also know about the internal source code of the libraries that we are using. So oftentimes they find solutions which are not even documented because they have direct access to the source code. And so they have been beneficial in that respect, but not to change the code itself, no. Finally, we have a feedback about upgrading to GeoServer 2.28 because the DDS build community module, which is also used by MapStore to power the Cesium terrain provider, is not working. Who to contact to fix this problem? You need to contact GeoSolutions. The module per se is community and thus unmaintained. Well, yeah, the first time we have a customer that wants to sponsor this development, we will definitely fix it. Will the fix for the legend also fix the problem that the legend cannot currently display wind barbs due to the complex expression? No, not that. That fix is specifically designed for, so Soren here is asking about this development here. Where is it? 228. This one. So no, this fix is specifically designed to work with recode, interpolate, and classify, and categorize, sorry, but not with other expressions. With the wind barbs thing, we would have to do some custom development that targets specifically that case and generates some sample wind barbs at certain speeds, not This is not something generic, let's say. Yeah, that's it. Is there any more question?
I believe that's all. Thank you, Andrea. Thanks for your expertise and sharing what's on the horizon with GeoServer 3 and what's happening with 228 now. Thank you also to everybody who's attending. As always, we want your feedback. We're always happy to talk with you more. You can reach us at either info@geosolutionsgroup.com or feel free to contact me directly anytime, ryan.burley@geosolutionsgroup.com. I see many people who registered who are attending right now who actually are, I know they have great applications leveraging open source geospatial software, specifically GeoServer. So let's stay connected and several of you have projects which would actually be interesting to learn from for the rest of the group. So that maybe that's something we can talk about in 2026. But yeah, thanks again for joining. Everybody have happy holidays. Merry Christmas, whatever
Right.
you celebrate. Have a great new year. And again, stay connected with us, and we look forward to working with you in 2026.
Thank you, everyone.
All right. Thanks, Andrea.
All right. See you around. Bye-bye.
So long.